Hello gentlemen, welcome back. Hopefully you guys are getting the hang of this elimination substitution methods. Today in this video we're going to work on looking at some more complicated problems. We're going to look at ways to get rid of some fractions. We're going to look at three equations with three unknowns, and then we're going to finish up by doing a word problem that's actually going to utilize one of these types of methods to solve for our unknowns. Okay, so let's get started here. The first example I want to look at has some fractions involved in it. Okay, we got x minus 1 all over 2 plus y plus 2 all over 3 is equal to 4, and x minus 2y is equal to 5. Obviously, this looks like a kind of a pain in the neck because I got some fractions in here. Obviously, I could think about using substitution. I could solve this for x, and then I could plug it back in, which eventually we will do. But the first thing that would be nice is to actually clear the fractions. And the way I'm going to clear my fractions is I'm going to multiply this entire equation up here by 6. All right, watch what happens when I do that. If I multiply equation 1 by 6, I'm going to have 3 times x minus 1. Again, stop this video if you don't see it and work it out for yourself. Plus 2 times y plus 2 is equal to 24. All right, what this just did was get rid of my fractions. It made this, it's the same equation. It means the exact same thing. But it just eliminated the fraction, makes life a lot more simple for me. Okay. Once I do that, what I want to do is simplify this a little bit further. And I can simplify this down to 3x plus 2y is equal to 23. So essentially, equation 1 and equation 3 are the same equation. I've just simplified them. All right. And this one right here is much more simple to use than the one above it. Okay. So now what I'm thinking about doing is, again, I have a system of equations, but instead of using 1 and 2 as my system, I'm going to use 2 and 3 as my system, okay? Because 3 is identical to 1. Now, having said that, what I would use, a couple different ways I could do it. I can use substitution, and I'm actually going to walk through substitution here, but I could also do elimination. It's actually set up really nice for elimination, because I can go x minus 2y is equal to 5, and I can go 3x plus 2y is equal to 23, and I can simply add and get 4x is equal to 28, or x is equal to 7, and then I can back solve and get a value for y. But let's do a little practice with substitution. We've been doing a lot of elimination. If I do substitution, I'd solve this equation right here for x. And I would get x is equal to 2y plus 5. Then what I would do is I would plug this right into there. And I would get 3 times 2y plus 5 plus 2y is equal to 23. Simplify, and I get y is equal to 1. At this point I would back solve. If I back solve, I would see that x is going to equal 7. You guys can go back and double check and see that 7,1 satisfies both of these equations. And again, going back to what we learned in the last video, I would say that this is an independent, consistent system. Okay, it's independent because it has one solution. It's consistent because it has at least one solution. Okay. Well, let's look at a system of 3 equations with 3 unknowns. And basically, what we want to do is we want to manipulate this system down to something that we already know, which is 2 equations with 2 unknowns. Okay, and to do that, I'm going to perform similar operations that I've done in the past. I'm going to avoid substitution here and look at elimination. I'm going to start with equations 1 and 3. If I add equations 1 and 3, like this, the z terms are going to cancel out, and I'm going to get left with 3x plus 5y is equal to 0. Okay, the goal is now is use equation 2, in either equation 1 or equation 3 to eliminate z. All right? And to do that, I'm going to multiply 1 by 3. I'll multiply this 1 by 3, and I'm going to add it to 2. If I do that, I get 6x plus 12y plus 3z is equal to 3. I want to add it to 2. X minus 2y minus 3z is equal to 2. The z terms cancel. And then if I have 7x plus 10y is equal to 5. If I look at equations 4 and 5, I have 2 equations and 2 unknowns. I know how to handle 2 equations with 2 unknowns. Okay? What I would do is still use elimination method, and I would multiply equation number 4 by -2. That's going to give me a negative 10y term here, and then I can get rid of the y's. So let's do that. Okay, I left this one alone. I left 5 alone. I multiplied 4 by -2. Negative 6x minus 10y is equal to 0. I can add those, and I'm going to get x is equal to 5. Okay? Now once I know x is equal to 5, what I can do is I can back solve. I can plug x, this value, into either equation 4 or 5. Let's plug it in. Doesn't matter right there. I'll get 15 plus 5y is equal to 0. So 15 plus 5y is equal to 0. 5y is equal to negative 15. So y should be equal to negative 3. Okay? So with back solve, we got y is equal to negative 3. Now what I want to do is I want to use any one of these 3 equations over here, plug in my x of 5, my y of negative 3, and solve for z. I'm going to use equation number 3. So I'm going to get 5 plus y, which is negative 3, minus z is equal to negative 1. I'm going to get 2 minus z is equal to negative 1. So z should equal 3. Okay? Like that. Alright? So hopefully that makes sense. So basically the strategy here was pick 2. Let's get rid of one of the variables. Here we got rid of z by using equations 1 and 3 right here to get that equation. And then I used 1 and 2 to get rid of z right there. Then I had 2 equations, 2 unknowns, and then I can use substitution or elimination. Let's do another one. Again, the strategy is going to be the same. This one's a little bit more work because I don't have all the coefficients are different. Not a big deal. We know how to handle that. Let's multiply 2 by 2 and add it to 1. Leave 1 alone. Multiply 2 by 2. I get 4x plus 8y minus 2z is equal to 14. If I add those, I'm getting rid of the z term. I get 9x plus 5y is equal to 17. Okay. Now I need to use, since I've already used 1 and 2, I have to use 3 for sure, and then I can either use equation 1 or equation 2. All right. Here I'm going to multiply equation 2 by 4 and then add it to 3. If I do that, I get 8x plus 16y minus 4z is equal to 28, and then I left 3 alone. If I add them, the z terms are going to go away. Like that. I have 9x plus 5y is equal to 31. Now I have this equation and this equation of only x and y, 2 equations, 2 unknowns. I know how to do that. The coefficients are the same, so I can actually subtract the 2 of them like that, and I get 0 equals 14. Haven't seen that yet. But basically what that's telling me is there's no solution. All right, because 0 does not equal 14. All right, and I'm going to note that there's no solution. If I got here 14 is equal to 14, what that would tell me is these are all 3 equations are identical. Okay, just off by a factor. Okay, and that's not the case here. Here we have no solution. So let's apply this now to a word problem. Okay, let's see how we can think about this in terms of a word problem. A basketball team scored 70 points in a game. The number of 2-point baskets was 2 more than the number of free throws. The number of free throws was 1 more than 2 times the number of 3-point baskets. What combination of scoring accounted for the team's 70 points? Again, sounds like a lot of words, but basically we have 3 ways to score. We can hit a 2-point basket, we can hit a free throw, or we can hit a 3-pointer. Okay? So let's let x, y, and z be my 3 variables there like this. We'll let x represent the number of 2-point shots, y equals the number of free throw, y equals the number of 3-point baskets, and z represents the number of free throws. Now let's break down what we know. We know we scored 70 points. So we can say that 2x, because I'm going to multiply 2 times the number of 2-point baskets, plus 3y, 3 times the number of 3-point baskets, plus z, because the free throw is worth 1, is equal to 70. I get that right off the first. 70 points were scored in the game. That's my first equation. Okay? Now, I obviously have 2 other unknowns, so I have to find other equations that are going to relate those variables together. Let's look at the next sentence. The number of 2-point baskets was 2 more than the number of free throws. The number of 2-point baskets, X, is equal to 2 more than the number of free throws. 2 plus Z. Okay? X is equal to 2 plus Z, or Z plus 2. There's another equation. I use this information right there. Okay? We need one more equation. The number of free throws, Z, was 1 more than 2 times the number of 3-point baskets. Z was 1 plus 2Y. Again, break it down. The number of 3-point baskets is equal to 2 times the number of 3-point baskets plus 1. The number of free throws was 1 more than 2 times the number of 3-point baskets. Okay, so you should be able to produce those 3 equations right there. Once I get to this, now I just have to figure out how to solve this equation. All right? The way I would do this is substitute 2 into 1. Substitute this value into equation 1. So wherever I see an X, I'm going to plug a Z plus 2. Okay? I can simplify that down, and I'll get 3Y plus 3Z is equal to 66. Okay? We're all set up for substitution now, because I know that Z is equal to 2Y plus 1. So what I can do is plug this right in for that Z. Right there. Okay? If I do that, I simplify 3Y plus 3 times 2Y plus 2 plus 1 is equal to 66. Now what I got is I got an equation with one unknown. I can simplify and solve for Y. Y is going to be equal to 7. If Y is equal to 7, now let's back substitute. That means that Z is equal to 15. And then if I back substitute the Z up into there, I should see that X is equal to 17. Okay? And so what does that mean? This means that the team made 17 2-point baskets, 15 free throws, and 7 3-point baskets. Again, I just took the words, a little problem solving here, took the words, made 3 equations. We just looked at how to solve 3 equations with 3 unknowns, and then we applied that concept. Okay? So here's some more work for you guys to do. I want you to read section 7.3. Look at those examples. Those are worthwhile. I got a few problems there for you to do. That should certainly help you reinforce these ideas and these concepts, especially with the 3 equations, 3 unknowns. It does take some practice. It does take some patience. Don't get frustrated with it. Make sure that you're working through it. Any questions that you guys have, make sure that you attended some Google Hangout sessions. Send me an email if you're unable to attend, and hopefully we can work something out. Okay? Have a good day. Thanks, fellas.